for you here from Lightbits Labs. Felix Milligan is the principal solution engineer over at Lightbits Labs. And I'm also going to have a lively Q&A with Felix after this. So again, keep those questions coming in. Felix, I think we are lucky here to have you because your name, I believe, if I'm not mistaken, in Latin means luck. Is that true?
Yeah, you could be right. I need to look it up, obviously. It's I just know myself as the same name as the cat, right? Famous cats, that's what I go for.
Nice. Awesome. Well, welcome here. I'll let you take it away and then I'll be joining you for some Q&A at the end.
Appreciate it. Thank you so much. Well, I know everyone's been on this call for a long time, so we'll try to say the best till last. Today, we're going to be talking about optimizing our Kubernetes environment with a data platform that scales just like your Kubernetes environment does. As we just mentioned, my name is Felix Milligan, and I'm Principal Solutions Engineer here at Lightbits Labs. So we can answer any technical questions as we go through. Please use the Q&A. I do have two people who are watching that Q&A and try and answer questions. And if we don't get to your question, we'll try and answer at the end. Should be about 20 minutes with about 5 minutes Q&A. Right, I have to try and stick to that now. So we're going to cover today. We're going to look at what companies are looking at from a modern Kubernetes solution. We're looking at limitation of common storage architectures. We're going to be looking at why use software-defined storage and NVMe over TCP. So that's a big hint about what Lightbits is and what we do. We're going to be looking at Lightbits for Kubernetes clouds, both public, private, and then the hybrid environment. We're going to be looking at the architectures and benchmarking of those environments. And then we're going to be looking at features and advantages specifically for agile DevOps. Finally, we're going to cover a couple of our customers and how their companies built Kubernetes clouds with Lightbits as the central storage platform. And like I said, we'll finish with some Q&A. Okay, so we've got a lot of data here for you. So what are customers actually using Kubernetes for, specifically when it comes to data-intensive services? And when I say data-intensive services, it means persistency in the storage. And usually it's high demand on that storage, whether it be large capacity or capacity and performance reasons. And these are three areas that you'll be very familiar with, right? Databases, analytics, and AI and machine learning. People are using Kubernetes for these stateful applications, right? Distributed databases that require high availability and huge scale. Analytics workloads, of course, require dramatic scale. And then AI and machine learning, which is obviously a huge buzzword and a boom at the moment, but people are definitely using Kubernetes in order to provide the scale out environment for those very, very integral workloads. Do you know what? The data is central to those workloads. You can't do AI and machine learning without a data set. You can't have a database without all the table information, right? So data is very, very important. So what do customers expect from a storage solution within their Kubernetes environment? Okay, so high availability is just an absolute given, right? And Kubernetes has some methods of doing this at the application side. You can use things like stateful sets to achieve this. But what happens when a disaster happens? What happens when maybe your stateful set isn't enough? Is your storage going to be resilient enough? And as people migrate and optimize applications from potentially bare metal through virtual into VMs and then into Kubernetes and containers and microservices, are people really thinking about that high availability aspect and critical data, how available that data is? Maybe you're looking at applications, but are you looking at the data those applications are using? People are looking at a unified platform for containers and VMs, right? Because a lot of people are in that transition phase, right? They're taking those monolithic applications that used to run on VMs, and you have best practices that you've been using for over 15, 20 years to run those applications, and then migrating them and pushing them into microservices. So they want a platform that can support both of those environments as they transition. Looking at central management plane, hey, ease of use, right? Maybe you want your platform to be able to plug straight into your Prometheus and Grafana, which is the same platform that you use to monitor your solutions, or any other platform that you're using to monitor your solutions. And then, towards the bottom here, but still a very high percentage of people who want the following, and that is high performance Kubernetes storage, automated capacity management. Kubernetes, in essence, is a very largely automated platform. We expect hyper scalability out of Kubernetes. Well, if the storage can't keep up with that scalability, then your applications are going to be bottlenecked or lagging behind. And finally, just a streamlined hybrid multi-cloud environment. Kubernetes is supposed to be composable. You're supposed to be able to deploy your applications anywhere using Kubernetes. So they want to maintain that for their Kubernetes environment and deploy it anywhere. Maybe they want to burst the cloud. Maybe they want to burst between data centers. That's something that they need to be able to do. Now, what our customers are telling us is that a lot of the existing storage solutions that they're using in their environments aren't working well for Kubernetes, right? So they're using either SAN, so storage area networking, the kind of old school buy an appliance, dual-headed, shared disk, and then present that maybe over SCSI or fiber channel. Or maybe they're using direct attached storage, local disk. Maybe they're using hyperconverged infrastructure where the compute is directly linked towards the storage. And if you need to scale, you need to scale both. All of those, they're telling us, just doesn't have the flexibility that they require with their Kubernetes infrastructure. And they need something that's more scalable. And then on the other side, if you're looking at kind of the native cloud storage, right, your Azures, your AWS, there's usually insufficient performance for those mission critical apps, right? Those highly performance intensive or latency sensitive applications. And if you can get the performance out of the cloud native storage, it comes with a premium, right? You have to pay a lot of money. You're often paying per IOP or per megabyte a second for that storage solution. And even if you can get that performance, it's usually not zonal, or it's zonal in nature, and you can't have the high availability of the storage, and therefore you need to turn back to the application. You need to application level replication, for example. Now, a lot of people try and overcome these limitations by building for these specific environments, and in the end, that's just going to lock you into a specific vendor or cloud platform because you're building your applications for an environment, and that's the complete opposite of what we want to do with Kubernetes. So Lightbits is trying to tackle these kind of three areas, right? Direct attached storage and the limitations that come with it, SAN and the traditional SANs and the limitations that come with them, as well as hyperconverged infrastructure and their limitations. I'll just talk about a couple of the limitations that we come across often when it comes to our customers migrating applications to Kubernetes or just running their applications across heterogeneous environments with Kubernetes. Often the first problem with SAN is that it's usually on a proprietary appliance, right? So that's where that vendor lock-in comes. Hey, you choose your vendor and you pretty much have to stick with them and upgrade with them for 5, 7, 10 years. Well, often you don't really understand your applications enough to be able to plan that far ahead, right? You need something that's composable, just like Kubernetes is. You want to be able to purchase hardware as you need it. For direct attached storage, for example, oftentimes people will just have a form factor and they deploy it, right? So you're basically creating hyperconvergence because you're deploying these infrastructure systems with maybe, let's say, 3, 4 terabyte NVMe devices or 4 terabyte NVMe devices because it's easier to do that way. But what you end up with is environments that are underutilized and over-provisioned. So you have a load of orphan storage hanging out there. Maybe you're not using the capacity, let alone the performance that you have. And there's a similar message with hyperconverged infrastructure. In order to scale those infrastructures, you have to purchase your compute and your storage together. So if you just need more compute for your Kubernetes environment, hey, you're purchasing storage. Well, I don't need it, and therefore I have orphan storage, and I basically wasted money on that spare storage that's sitting out there being underutilized. With all of this comes cost. So if you're building a cloud or cloud native applications, you're effectively building your own cloud. Whether you're utilizing the public cloud or whether you're building your own internal cloud with your own infrastructure on premises or in a data center like a colo, all of these cost a lot of money, right? You're usually trying to get more performance for your applications. And so you're dropping a lot of money on very expensive storage, and then you're not using it. So as I said before, you often run into these storage performance bottlenecks because maybe you've under-provisioned your storage for a specific workload, or maybe Kubernetes is migrating your workloads between machines, and these different machines are truly heterogeneous, and they have different storage footprints. And then there's always the scalability limitations as well. Like I said before, maybe your applications just need more compute. Maybe you just need a bit more memory, but you don't want storage as well. Maybe you just need storage and your compute levels are fine. You're just increasing the capacity that your applications require. That's a really common use case too. So how does Lightbits overcome these issues? So Lightbits is a software-defined block storage piece of software, which is highly scalable and highly available at all times. We have our own CSI plugin, and so we run these storage-intensive applications in containers at very, very low latency with incredibly high performance limits. So you can run millions of IOPS to your applications and not have to worry about how the storage is composed in the backend. We have a huge cluster of Lightbits, you have a huge Kubernetes cluster, and your applications just pick up storage as they need it. Therefore, we're removing those storage performance bottlenecks, but also we're cutting costs of applications because we're better utilizing our storage that we need. If all of your applications are drawing from the storage pool, in order to increase the amount of storage, you just need to increase the storage pool and all your applications can then grow, not per node on the Kubernetes side. We're providing you ultra high availability for stronger data protection with up to 3 copies throughout the cluster, as well as just that whole idea of having a cloud scale flexible storage solution. And we're built all on top of NVMe over TCP. So that means you don't have to change your underlying networking in order to use Lightbits. So this is kind of how it looks like, right? We have our Lightbits cluster, which is NVMe backed, providing NVMe TCP over TCP IP networking over Ethernet, end-to-end NVMe style performance with low latency and high performance. And then we scale the storage and compute independently. So your applications can grow naturally rather than having to fit in an infrastructure form factor. We have intelligent flash management, which enables you to use QLC, cheaper SSDs for the ultimate price performance. And we also extend the flash endurance by 20% using this intelligent flash management capability. So we have no service disruption after a node or drive loss. There's redundancy all throughout the infrastructure stack, from drive to CPU to networking. So we can always handle any issues that happen in the data center, just like your Kubernetes infrastructure should be able to. Non-destructive rolling software upgrades, which you'd expect. And like I said, up to 3-way replication. And this takes this concept of failure domains into consideration. So you can set separate areas of maybe power cooling in the data center or in the cloud zones, and they can become your failure domains, just like you'd have in your Kubernetes cluster. So you might be new to NVMe TCP. You might not have heard about it, but it's been around for a very long time now. And as you can see, lots of companies are starting to adopt or have already adopted the NVMe TCP protocol. It effectively enables you to run very, very high performance storage across standard Ethernet networking. And our customers range from maybe just 25 gig links all the way up to 100 gig plus links between the storage and their compute nodes, depending on their application requirements. So it's extremely high performance and very low latency. We're talking about a couple of 100 microseconds of latency for hundreds of thousands or millions of IOPS. So how does it look in practice? Well, you've got your Kubernetes worker nodes on the left-hand side and your master nodes as well. Your worker nodes are running your applications, right? So those worker nodes individually will connect to Lightbits over standard Ethernet and NVMe TCP. And those volumes will be placed across the cluster and replicated on the right-hand side on the Lightbits side. Now, we have our CSI driver. It's actually open source as well, so you can check out the code in it. We use that CSI driver. Your applications can use persistent volume claims to set up those volumes on the Lightbits side, those block storage volumes. And then the CSI driver will create a persistent volume with a file system on those worker nodes. And your worker nodes can then just use that storage for their applications. What this gives you is the ability to migrate workloads between nodes, or for Kubernetes to migrate workloads between nodes and still maintain that same storage on the right-hand side. So less replication on the application layer and more resiliency. This is the tech stack. So you've got orchestration by Kubernetes, you've got all your applications in pods running using the CSI driver, which is creating volumes on the Lightbits storage and connecting to them via NVMe over TCP using standard TCP/IP Ethernet networking. So you can effectively use your current built-in infrastructure, but get extremely high performance that you might think you'd need to buy purpose-built infrastructure for. And that already saves you money. And we do work in the cloud as well. So we have an on-prem offering, software defined, just install on NVMe-backed hardware, and then Lightbits can create a cluster out of those infrastructure nodes. Or we can deploy in AWS or Azure. And we work natively with AKS or EKS as well. So you can use Lightbits in Azure, on-prem, or in AWS, same infrastructure in the backend effectively, same software running in all three. And therefore your Kubernetes clusters, wherever they're running, get the same look and feel of using Lightbits with very high performance block storage. Now, Lightbits in the cloud specifically really overcomes some performance bottlenecks that we've had from customers. Expensive cloud storage just not giving the latency, performance, or durability that they require. And then they've moved to Lightbits and they found that none of that is a concern anymore. Lightbits is already highly available. We are high performance, and we also are generally cheaper than the cloud native solutions as well. So we save you money. Even if you're not having to over provision that storage for performance, which people often do and spending more money on that, we can optimize environments in other ways as well. This is an example of Lightbits against Ceph. This is a really common configuration that Lightbits gets compared to, mostly because we are software defined, hyperscalable storage, and Ceph is the same thing. But as you can see, Lightbits is a completely different level. And this is where not having to worry about your environment really comes into play. So like 4K, 100% reads, 3.94, nearly 4 times the performance of those small block sizes. For writes, we're up to 60, nearly 17 times the performance of Ceph. And even in a kind of 80-20 environment with 8K, 12.5 times performance than the equivalent Ceph. And that's on a 12-node Kubernetes environment with identical hardware configuration on the Lightbits and the Ceph side. So same price for both infrastructures, but you get a whole lot more with Lightbits. In terms of DevOps, which, I mean, often Kubernetes environments are just suited for DevOps. You have the whole CI/CD pipeline where you're developing, you're building, you're deploying, you're monitoring, and then you're changing again, optimizing. So with Lightbits, we use thin clones and snapshots, and that's using the native Kubernetes snapshotting tools in order to rapidly spin up new environments, clone real-life data into immutable clones, and then use that for your DevOps environment. So your developers can have access to genuine data, but you don't have to worry about them modifying the original data set. That's still protected. That is completely immutable from those cloned environments. And then you just destroy them when you're done. And you keep that process going. So some examples of customers that we've helped already. A huge e-commerce giant who built their Kubernetes environment on Lightbits. They have millions of users with millions of daily visits and millions of monthly shipments they have to track. Lightbits underpins this entire environment with a range of workloads. Kafka, MySQL, MongoDB, Aerospike, Cassandra, HBase, Redis, Elasticsearch. I'm sure all of these are applications that you run in your Kubernetes environment today. This customer runs all of that on Lightbits because what they want is an approach for their data centers that is as scalable as their applications must be. E-commerce in nature is highly scalable. There's always busy periods and downtime. And so the applications need to scale with those busy periods and downtime, but so does their storage. And Lightbits helps them do that. Now, they're not just on premises, they also run in the Azure cloud. So we're helping them in both environments. What they found with Lightbits is that they get huge flexibility. So they can run on any cloud or hardware configuration with our CSI. And you know what? We've been with them long enough. They've been through iterations of hardware in the back end. And so they have a pretty much heterogeneous environment that Lightbits runs on top of. Different vendors, different hardware, running the same Lightbits platform. They get independent scaling in any direction for performance or capacity, i.e. when those busy periods happen, maybe it's just their compute nodes that need to scale. So they can do that without having to scale their storage as well, and that saves them cost. And that affects their bottom line and increases their ROI. And then there's the efficiency of having a really resilient storage with that local flash performance, right? Direct attached storage isn't resilient. You can lose a drive and you lose the entire node. Drives go down, they fail, that happens. But with Lightbits, not only are we protecting at the drive layer, but we're also protecting at the volume layer with replicas. So multiple things can go wrong, and you can still be chugging along absolutely happily with your storage. And then they have that agility, the agility to move and shift applications around different environments and allocate storage to any cloud at any time. Another example is MetalStack. So MetalStack are a company out of EMEA who launched Kubernetes as a service with Lightbits underpinning that service. So they provide Kubernetes as a service on bare metal with elastic cloud infrastructure. They want high performance because they want to target very demanding applications. They have strict data protection and security compliance because of the EU regulations. And they want strong tenant separation, so RBAC controls, so they can serve multiple customers with a kind of single back-end infrastructure. They also don't want to affect other customers with noise neighbor syndrome, for example. They want streamlined management and self-service API for customers. And lucky for them, Lightbits is fully API driven. So if you need to do more than the CSI can provide you, you can automate that process extremely simply with Lightbits. So what have they found? They found that our performance absolutely rivals local flash, but we have incredible scalability. You're no longer linked between compute and storage. Lightbits provides you that flash performance with disaggregation, the benefits of that independent scalability. Because they're using persistent storage claims or persistent volume claims with persistent storage backends, it means that their storage is disaggregated from their compute, which means they can scale compute resources independently, but it also means that they can reduce form factors or buy slightly cheaper client specs because they don't have to size them out for the storage as well. So you offload a lot of the storage CPU power that you need to run local storage. You offload that to Lightbits. And then they have that clustered architecture, super high availability, built-in snapshotting, and efficiencies such as compression. And you can even encrypt end-to-end using the Lightbits CSI plugin. And this all competes with hyperscalers and their native cloud solutions. It's a really good competitor, very high performance, low cost, and hyper scalable. And they're rivaling people like AKS and EKS. So in summary, what's the value of Lightbits, especially for Kubernetes? So we are absolutely ideal for Kubernetes because we are available for private Kubernetes environments, on-prem or in colos, as well as Azure, as well as AWS. We deliver very, very high performance, and this isn't for the cluster. This is on the client side. 4 million IOPS for storage-intensive Kubernetes apps on a single node. That's very, very high performance. More performance than you'll probably need. But you spread an entire cluster's worth of performance across a large Kubernetes environment, and that's where you need that performance. We have low TCO to control those on-premises costs, the ability to use QLC devices, for example, as well as have that kind of composable back-end infrastructure, which means that you can save costs by going to your favorite vendor rather than having to buy a full appliance and then you're stuck with that appliance for a period of time. You can effectively look at which OEM makes more sense and go with them, maybe even every year. I don't know how your environment is, but some of our customers do change that often. You got snapshots and clones for DevOps, obviously thin snapshots and clones, so you're not taking up a bunch of storage on the storage backend just because you want to do DevOps, right? Everything is thin, so you won't even really see a huge performance or a huge capacity increase when you're running your CI/CD pipelines. We are fully software defined, being able to support actually thousands of Kubernetes nodes per Lightbits cluster with thousands, tens of thousands of volumes or persistent volume claims on a single Lightbits cluster. We're built on NVMe TCP, which gives us that edge to be able to use that standard TCP/IP networking, but still provide that extreme high performance. And not only that, not only are we durable at all the different layers of the hardware stack, but we can heal ourselves and scale incredibly easily. If you need more storage, you can either put more drives in the bays of the Lightbits nodes, or you can add Lightbits nodes to a Lightbits cluster. And because of the way that we allocate volumes across the cluster, they're spread completely across the cluster between your failure domains. And therefore, your Kubernetes environment can start using the new nodes. And Lightbits will even balance volumes based on capacity for you. So you don't have to worry about that. You just have to worry about ensuring that your Kubernetes environment runs smoothly. I had a customer say the other day that we were an absolute set and forget solution. They didn't have to worry about us when they woke up in the morning. They just run their applications on us and don't have to worry. And that's a huge thing in an infrastructure environment. So you get your network and clients unchanged using maybe off the shelf or infrastructure that you already have in your data center and repurposing. We get multi-tenancy, and more importantly, there's no proprietary software on the client itself. NVMe of the TCP is built into the Linux kernel already. And so there's no agent on the client. There's no software that Lightbits manages on the client. We obviously have our CSI, which is open source. But everything else is just composable. And then we have our intelligent flash management, thin provisioning, compressioning, thin snapshots and clones, and that built-in data protection, so you know your data is safe. So I'm going to go to the Q&A portion now. Hopefully you've learned a little bit more about Lightbits and how we can help you on your Kubernetes journey and in your environment. And if you've got any questions, please shout them out.
All right, excellent. So we definitely have some questions that have come in while you were presenting. So I'm going to pose some of these to you now. And if you guys do have more questions, feel free to throw them in the chat and we'll give them a quick review as well as we come to wrap things up here. I'm going to leave this up just a minute, these QR codes. So if anyone's looking to learn more about Lightbits or talk to Lightbits, grab those now, and then I will throw up a final poll about halfway through the questions here. But I'll give you a little time to check those out. And with that, okay, Felix, question number 1, let's dive into it. Someone is asking here, which databases have you or the customers at Lightbits already tested?
We have customers using a bunch of different databases. One of the customer case studies actually went through a few: Kafka, Elasticsearch, MongoDB, MySQL. If it's a workload that requires high performance storage and it runs in Kubernetes, one of our customers has probably run it. So logging platforms or databases, all of the above, really. Cassandra is a big one as well. Kubernetes lends itself to these really scale out databases that kind of need to scale for performance purposes or maybe capacity purposes. So, you know, the Kafkas, the Cassandras of the world, we work really, really well with that. Postgres is another huge one that our customers like us for, especially with some of the work that's been done recently with PostgreSQL performance in Kubernetes. You're seeing a lot of Postgres.
Okay, excellent. I've just got a bunch of questions to throw them at you here. Next one is, how does Lightbits handle data redundancy and failover in case of hardware or network failures?
It's a good question. So I talked a little bit about the fact that we have redundancy of the stack. So the drive layer, we have erasure coding. So if you lose a single drive, no problem at all. That node will still keep going, serving data. Now, if you lose a second drive, as long as the data is rebalanced, because we fix ourselves as well in the back end, we actually provide N+1 data durability at the drive layer. So if you have 8 drives and you lose one and you have 7 left, as long as you have capacity to balance the rest of the data across the remaining drives, once the data has been rebuilt, we can lose another drive and you can end up with 6. You can keep doing that until you end up running out of capacity in the back end. So huge redundancy at the drive layer. And you can also add drives in a similar way. You know, live add drives if you need to scale up. Now, in terms of resiliency across nodes, for example, in a cluster, we do replication. So every persistent volume, you can select a replica count. And that can be 1, maybe for DevOps, or scratch space. It can be 2, or it can be 3. So you can have up to 3 copies of each persistent volume across the cluster and separated by failure domain. So if a node fails or you lose multiple drives at the same time, or you have a network issue between your clients and the nodes or the nodes themselves, or maybe you're just running, a BIOS upgrade, then your data is absolutely safe and you still have the remaining copies of the data. And NVMe over TCP, incredibly smart as a protocol. The client actually connects to every target in the cluster, which means it doesn't matter where your volumes are. If a node fails, they'll just pick up another path to the cluster. So it's extremely resilient.
Incredible. Our keynote speaker today mentioned if you didn't have 3 copies of your data, it doesn't exist. So I think this kind of covers that.
Two is one and one is none is what I was always told.
Okay,
so you need
like
at least
that.
3 because then you have 2.
Love that. See, these are good takeaways today. Things I'm learning. I'm always learning. So I got to quickly throw up the poll. So if you are out in the audience and you're curious about some more information from Lightbits Labs, just let them know what you're looking for. Data sheets, pricing details, personal demos, a white paper, etc. I'm going to leave that up while we go through a few more questions. I've got a question that came in from Michael Wish. He's asking, does Lightbits use its own proprietary file system?
No, we don't actually. So that's a really good question. So Lightbits provides block storage to the clients, and then our CSI overlays standard file systems on top of it. Now that could be XFS, it could be ext4. Really, Lightbits as a storage is block, and then you can overlay any file system at the client side. That's one of the beauties of it. It's extremely high performance block storage, which means that it has high levels of usage that you can kind of tune to what you need.
Okay, excellent. Next in the queue is what management tools and interfaces does Lightbits provide for monitoring and maintaining storage in Kubernetes?
It's a good question. So Lightbits is fully API driven, as I said. When we're talking about monitoring, we like to fit in with our customers' environments. So today, most of our customers use what we call our exporter, which exports metrics into Prometheus, and then they usually just display that in Grafana. It's one of the most common ways to monitor Kubernetes and generally IT environments today, but we can work with many different environments. So 90% of our customers, really, they just kind of push it to Prometheus, and then they deal with it. They have to display it in Grafana or some other tool sets, and then they usually do their alerting that way as well. So net, we kind of like to fit in with whatever our customers are doing, but we can work with a lot.
Very nice. Highly flexible.
Exactly. That's a good word. I should have used that.
Anytime, use it up. So we are kind of coming to the end of time, but any final call to action or anywhere you'd like to point those who are curious to check out more about Lightbits that are in the audience today?
Yeah, sure. So first, visit our website, www.lightbitslabs.com. There's plenty of information there. We have Kubernetes pages. We have cloud-specific pages, whether it be private or public cloud, white papers, blogs, you name it. We have a bunch of things on our website you can start off with. Also, all of our documentation is completely public. So if you want to see how easy it is to deploy Lightbits, you can go to our website, look at our documentation, and see yourself. Now, if you want to try us out, if you want to do it on-prem, you can get in touch with us. If you want to do it in the cloud, we're available in the AWS and Azure Marketplace, and you can deploy us on your own without having to ever talk to me, if that's your kind of thing. I know a lot of devs are like that, especially with Kubernetes. You kind of want to try it yourself before talking to anyone. So if you're in the cloud, you can do that.
Awesome. Excellent. Well, great place to go. If you are out there and curious, you know where to go now. And then again, we also have our handout from Lightbits, the solution brief, Lightbits persistent storage for Kubernetes. So make sure you go grab that before we wrap up today. And with that, I am going to say thank you so much one final time. And hopefully we'll have you back, Felix. And it was great having you on the EcoCast today.
Thanks so much. I really appreciate it. Thanks everyone for listening.
A pleasure. Until next time.